Okay. Hi everyone. I really miss you guys a lot. I can't wait to see you. I hope that you're all staying safe and well. So, last time we saw each other, I told you guys that I wanted you to rest because in term 2 I'm gonna need you guys to push and be, ready. So not duds and half dead like you were. Okay, so now I'm guessing we're going to have to, I need you guys sharp in the comfort of your home. Okay, so how my lessons will work is I will present my lessons on a video like now. Okay, I'm using this cool system, shout out to Mr. Miller and Mr. Marais, where I can actually switch between my webcam where you guys can see me and you can see the whiteboard behind me where I'll do some of the work. Then I can also switch to my document camera where you guys can actually see the notes, because I'm not sure whether you can actually have the notes and the video, watch the video simultaneously. And then I can also switch to my desktop where I can show you guys or where we can look at specific slides in the PowerPoint, or where I can show you sections of cool video or YouTube clips. Okay, so how this is going to work for the next 3 weeks is I'm going to upload a lesson, right, where I record, I do an explanation, we look at some of the notes. Okay, I'm going to upload 2 files. There'll be PDF files. I'll upload them on the e-learning portal as well as Class Dojo. I'm going to focus on the e-learning portal more because it gives me freedom to pay or to put up slightly longer videos, right? And they're not as big, but it just means that I can get kind of like a full lesson in. Remember that this section, this term's work is mechanical engineering. So even though the concepts aren't necessarily difficult, it is not something that you can just read through and understand. That's why I'm presenting the lessons. Okay, so the first 2 documents that I will upload for you guys will be PDF documents. The first one is the notes that will cover this entire section. All right, so the next 3 weeks. It is from the Technology Today book. Please also look at your textbooks if there are any other cool pictures or explanations that work better for you. Okay, then I'm also going to upload like lockdown planning, which is simply like kind of a breakdown of which topics we'll do, what my role will be, what your role will be. You will see on this that it also asks you to submit evidence of work done, right? All activities and tasks that we do, I want you to do them in your workbook. So you write the date, you write the topic heading. Okay, so if you watch the video and there's something important that stands out for you, you make notes in your workbook, just like you would have if I was teaching the class at school. Okay, then also from the notes that I give you, there are some important sections that you can write in your workbook as well, kind of like not a summary, but kind of pointing out the most important parts. Then if there's anything that I do on the board with you, some activities I'll actually do on the board with you, I want you to please write it in your book as well, and then just write their classwork or done with Mrs. Marais. Okay, so then just to make sure that you guys are staying up to date and that everybody is actually doing their part, and so that if there are issues, I can try and resolve them. I'm going to request you guys to just submit like a photo of the work that you've done on the e-learning portal and Class Dojo. This is just to keep track. It's not like I'm going to give you demerits if it's not done. This is simply because I want to help you. If I see, for example, Sunny hasn't been uploading things, then I can try and find out why, what's the problem. Is there something that Sunny doesn't understand? And how can I help? All right. So that's basically how the next 3 weeks are going to work. Right. Then we have Class Dojo, as well as our WhatsApp group on which you guys can then ask me questions. The cool thing about this is that you guys can watch the video over and over, and if there's something you don't understand, then activities given, you can do them, and then you can ask me on the WhatsApp group if you have any concerns or any questions. Some I'll answer on the WhatsApp group. If there is a general issue, then in the video where I actually mark the activity with you, I will address them. Some activities I will actually mark with you in the form of a video like this one, where I actually do the answers with you on the whiteboard. Some I'll just give you the memo and you must do it. I've tried to break the stuff down in smaller sections so that the work that I give to you is actually doable. I hope that by now your maths and languages and science teachers, have worked with you guys and are slightly ahead, so that you now have slightly more time for technology, which is why I'm only starting to teach now, because I've been giving them a gap to get as much work done as possible. If there are any issues, or you feel I'm going too fast, or there's something you don't understand, you want me to put up another lesson explaining that, then please just let me know on the WhatsApp group, and then I can do that for you guys. Remember, I just want you guys to know that if this is difficult for you, it's even more scary for me. You guys know I teach technology, but I'm not good with technology, and you guys aren't here to help me. So, forgive me from the beginning, it's still a bit iffy, and, I still struggle a bit with the system. Okay, so, work will be uploaded. You watch the video, you check out the notes, you do the activities in your book, and then you simply submit a photo of the work done. This is just for me to see, how many people are doing the work and to solve any problems. Okay, so I think I'm starting to repeat myself. All right, so the first section that we'll be doing this term is pneumatics and hydraulics. Okay, now remember we did this in grade 7. Okay, so the first section of my video is basically going to be the introduction to the chapter, as well as just some revision from work that we've done in grade 7. And here you will see the importance of levers that I emphasized in grade 7, and gears and mechanical advantage that I emphasized in grade 8, because those same principles apply. Okay, Pascal's principle it's not undoable. Yes, it is a difficult concept, but it is very important that you make sure you understand, and that if you don't understand, you let me know. Okay, because these are your free marks. And yes, it is maths, it's calculations, but you know by now that in technology, calculations are your free marks. So it's like mechanical advantage calculations, solve for X calculations. Unfortunately, in technology, especially in this section, you get marks for method. All right, so even though you can get to the answer using a different method, okay, it is important that you use the method that I teach you in the tests and exams. You can use your different method to double check your answer, right? But it is important that you use the method that I teach you. Okay, please remember also that in this we'll do a lot of exercises, and practice makes perfect. Okay, these are word sums, which means same as with gears, we write down the information, and from there we do the calculations. Okay, there is a reason why I hammered on it. Okay, I know at that point you guys thought I was being extra. Now you'll start to understand it. Okay, so the first section that we'll be starting with is pneumatics and hydraulics. It consists of 3 sections: Pascal's principle, then we look at the hydraulic press, and then we look at the hydraulic jack. Okay, with these you'll see I've uploaded some YouTube clips. I will not be showing all of them to you guys in these videos, but I will be showing like sections from them. Please watch these, right? These are crucial to you understanding the work. There are many others out there, and you can watch more of them if you'd like, but it is important that you watch the ones that I have given and the ones in the PowerPoints. This is just, sometimes technology is visual, it's practical, so if you see it, it makes more sense. All right, okay, so this cool system allows me to switch through different things. Okay, so your notes, let's just start with an overview of what the planning is going to look like. Right. Okay, so, I'm so proud of myself. All right, so here is just a basic example of what the planning looks like. Of course, you know, this is me, nothing is set in stone. All right, but here's more or less, okay, today this is the work that we're going to cover. These are the notes. This is what you'll be doing, and then what you will have for homework. This worksheet, you will see I will upload as a PDF. I'm sorry, in the heading I've labeled it as exercise and not worksheet, sorry. Okay, so this is what we'll be covering today. Okay, so with this, stay with me, go through the notes several times, and then ask me any questions. This specific thing is one of the PDFs that I will be sending to you guys. Okay, right, next we start with the first section, which is pneumatics and hydraulics. Okay, now I'm just going to move this a bit so that you guys can see the notes better. I'm sorry if this lags a bit, but my document cam is a bit, okay. Right, so this is just key concepts. Okay, so just to go through this very quickly, pneumatic systems use compressed air to transfer force. Important, okay, they transfer force. Okay, hydraulic systems use liquid to transfer force. What makes it very cool to use these systems, besides the fact that they can give us mechanical advantage, is that by using pipes and tubes, you can bend them to fit into small places or to reach hard to reach areas. For example, the braking system of your car. You want the pedal there where your foot is, but you want, so that would be your input, but you want your output to be where the wheels are. Okay, so then just Pascal's principle is basically that a change in pressure. Okay, now here, pressure is a concept of a force that is transmitted, okay, that presses equally against all the area around it, okay, the surface area around it. For pneumatics and hydraulics to work, it is in an enclosed system, okay, which means there's no open space where water can squirt out or air can go out. Okay, so it is transmitted, meaning passed on, undiminished. Okay, to diminish means to make smaller, so undiminished without being made smaller to all points of the fluid. Okay, because pressure is force on surface area, it is passed on through all points. Okay, then the different parts we'll be looking at, sorry you can't really see my highlighted stuff so nicely on here, okay, is we'll be looking at Pascal's principle first. Okay, I know this seems daunting at first, but hang in there and remember I've got you guys. Okay, then we'll look at the hydraulic press. Okay, and then of course we'll look at mechanical advantage. Remember, we don't use a mechanism for no reason. Okay, and remember, technology is the manipulation of mechanisms, okay, to get the output that you want. Okay, so just like with levers, right, if you wanted it to simply transfer the force or the movement, then you had a seesaw. Okay, first class lever, fulcrum exactly in the middle. Okay, so mechanical advantage is equal to 1. In gears, if you simply wanted mechanical advantage equal to 1, the gears had to be the same size. Okay, if you wanted mechanical advantage in gears, okay, now remember, in any mechanism there's a compromise. Okay, in levers it was force and distance. Okay, then in gears it was force, and then your compromise was velocity and speed. Okay, and you manipulated the system based on what you want as an outcome. Okay, so you manipulated the system based on what you want as an outcome. Okay, and for that I'll just very briefly explain it on here. Okay, so basically, all right, with gears. Okay, all right. So if you mechanical advantage is equal to 1. Oh, sorry. Mechanical advantage is equal to 1. Right? Then you have 2 same sized gears. Okay. Same size. All right. If you wanted mechanical advantage bigger than 1, okay, meaning you wanted force to go up and you wanted, and if force goes up, velocity goes down. So here you had as a driver gear, a small one, and a driven gear, a big one. Okay, so basically shimmy and beast. Okay, beast is big, okay, so strong but slow. Okay, so in this scenario, to get mechanical advantage is bigger than 1, force goes up, velocity goes down. So you will manipulate the system, small driver, big driven. Okay, if you want mechanical advantage is smaller than 1, okay, which means force goes down but velocity goes up. So the outcome that you want is speed. Okay, here your outcome was force. Okay, so easier. Okay, here is speed. Okay, then you have a big driver versus a small driven. Okay, so beast versus shimmy. Okay, shimmy is fast. Ooh. Fast, but not so strong. Okay, fast but not so strong. So this is basically the basic concept of mechanical advantage and the compromise in gears. Okay, so this is simple revision. Okay, so for that now we'll go back to our notes. Oh, sorry if I'm making you guys dizzy. Sorry. Okay, oh, there's my problem. Okay, so here we'll just look at mechanical advantage, and in hydraulics it is based on the size of the cylinder. Okay, then also look at the hydraulic jack. Okay, and with this I give you guys 2 really cool YouTube clips to watch that really explain it nicely. The one especially has an Indian guy that has like an awesome accent. Yes, the first 2 seconds laugh at his accent and then actually listen to what he's saying. Okay, so now I'm going to switch and I'm going to look at the next page of our notes. Okay, so this section you can read through. It is just a revision of the work that you've done in grade 7 and the jaws of life. Okay, you know by now that I don't strictly teach out of the textbook, so shortly I will move to my webcam where you guys can see me and I'll do some demonstrations. Important concepts that you must know is what does compressed air mean, and then the definition of pneumatics, the definition of hydraulics. Okay, now here you will see this is revising, so revising grade 7 work. Okay, so this is, you know, grade 7 was very, very long ago. Some of us have forgotten. Some of us didn't do it in as much detail as I did it with you guys. Okay, so force transfer in syringes using air, which is pneumatics, and liquid, which is hydraulics. Okay, and the first part that we'll be looking at is the force transfer between 2 equal sized syringes with air and with water. Okay, you'll see on the next page, okay, they just describe all of that for you in words. Okay, where I come in, this is where I come in, I explain it to you guys. So now let's see. Okay, that one. Yay, I'm back. All right. Okay. So, I've now given you some ideas for thought. I've explained to some extent the relationship between mechanical advantage, which is force, and the compromise, which is distance in the case of hydraulics. Okay, first one to show in pneumatics. Okay, so here I have I hope you guys can see. Okay, I have a pair of syringes. Okay, now the outside of the syringe is called the cylinder, and then that black part and this handly part is called your piston. Okay, don't ask me. That's just what they're called. Okay, now here I have two equal sized cylinders. Okay, both of them are 10 ml syringes. Okay, now this is filled with air, so it's a pneumatic system. Okay, now remember, pneumatic systems use compressed air. This specific example that I have here for you guys is simply filled with air around us. Okay, and we know that that air is not compressed. Okay, now here comes in your knowledge and what you've learned in natural sciences. You learned about the particle model of matter, the model of, okay, in which basically between gases, the spaces are very big. Okay, so here I have just normal air, okay, where the spaces between the particles are very big. So if you look at how far, okay, let me switch this, okay, look at how far I press this input, okay, before the output starts moving. You will notice that that is because the air first needed to be compressed. If I keep it there and I apply just the least amount of pressure here at the bottom, you will see how far I can move that before it starts moving on the output. Okay, in one of the PowerPoints you will see that they speak of master cylinders and slave cylinders. Okay, master is simply input, slave output. These are the terms that they use in the industry. Don't ask me why. You'll realize that I prefer to refer to them as my input, okay, and my output. All right, so here I have an example of just a pneumatic system that is filled with normal air. If it was filled with compressed air, then it would move equally, because in compressed air, the spaces between the particles has been made smaller. Not small enough that it changes phase from gas to liquid, but much smaller. Okay, so here also you will notice I have two equal sized syringes, okay, which means, okay, gears the same size, okay, cylinders the same size, which means mechanical advantage is equal to 1. The force that I apply here, okay, is transmitted undiminished. It's transmitted, passed on without any loss. There are no open spaces where some of the air can come out. Okay, it's passed without any loss to all parts of the system, and the only part that can move is my output piston. Okay, so two equal sized syringes, which means, okay, the force that I apply here on my input, okay, is equally transferred to my output. Also, if you look closer, the distance, okay, is the same. Okay, let me try and get them the same size, same height. Okay, the distance is the same. Okay, so here you have an example of a pneumatic system. Okay, this is a very simple system. Okay, these are syringes that I'm using. They're not perfectly airtight. Here the tubes and the places where we've attached them are not perfectly airtight. In industry, they use better materials and their connections are absolutely airtight. Right, next we'll look at hydraulics. Okay, same setup. Okay, a closed system. Enclosed system, okay, there's no place where any of this water can squeeze out or squirt out. The only thing that can move is my output. Okay, so the difference between this and the previous one is this one is filled with liquid. In this case, it is simply water that I've put in some food coloring. Okay, I hope you guys can see better. Okay, so then this is my input, okay, and this is my output. Right, because they are the same size cylinders, 2 10 ml syringes, okay, if I push it, the force is transferred equally and the distance is equal. So my input force is equal to my output force, and my input distance is equal to my output distance, which means mechanical advantage is equal to 1. Okay, right. Now this is water, which is still slightly compressible. In industry, they use oil. Okay, right. So then the next one that I want to show you guys is cylinders of different sizes. Okay, cylinders of different sizes. Now for explanation purposes, I have a 10 milliliter syringe and a 5 milliliter syringe. Okay, 10 milliliter syringe and 5 milliliter syringe. Okay, so at this point, okay, this one is going to be my input. Now remember, you manipulate the system based on what you want as an output. Okay, so let's just compare the distance quickly. Well, I guess you'll need it there. Okay. Right, do you see that in the output, which is this one, it moved much further than it did in the input? Let me do it for you guys again. Okay, so there we go. Okay, right, so remember our compromise with hydraulics is force versus distance. Okay, so in this specific case, I had big input cylinder, so beast, okay, and smaller output cylinder, shimmy, okay, which means force becomes less, but distance becomes more. Okay, so depending on what you want as an outcome. All right, do you want to lift something much further, or do you want to lift something that is very heavy? Okay, so this, in this example, where the input is big cylinder, output is smaller cylinder, here I want to lift something higher. Okay, it's not necessarily as heavy, but I want to lift it very high. Okay, if I take this exact system and I switch it around, okay, like I showed you guys with the gear notes, okay, now my input is a small cylinder, shimmy, my output is larger, beast. Okay, so I will have more force but less distance, and let's compare them again. Okay, right. Okay, now remember they're much smaller, so what you will have noticed is that in the big syringe it will have moved half the distance. Okay, so here in this specific case, all right, I want more force as an output, and I'm willing to sacrifice distance. Okay, now this specific concept links us back to our Jaws of Life that we did in grade 7. Okay, now some of you will remember this. This is actually one of the learners examples, so it's not completely perfect. They stuck the syringe a bit too low, but I'm going to show you in any case. Okay, so Jaws of Life is a system used by paramedics and rescue workers. Okay, it is a hydraulic system that multiplies force. Okay, because you get 3 basic kinds. Okay, you get a cutter, which works as a scissor. Okay, so for example, sometimes they would cut through the parts of the car. For example, you know, those parts between the doors and the part between the door and the windscreen, and they'll cut that open so that they can literally lift the top of the car off to get to the injured person. All right, so a cutter. Then the other one is a spreader, where they actually squeeze it in and they spread it open so that they can reach someone. And then you also have the ram, okay, which is basically a thing that you put in. They are usually round, and then it literally pushes 2 sections apart. This is often used by emergency workers in, for example, earthquakes, where a building has collapsed and now there are 2 pieces of concrete that are, you know, pushing against each other, and they need to separate them to get to the trapped people. Okay, so in this example that you guys made in grade 7, okay, this is actually a combination of a cutter and a spreader, okay, because if it is completely done, they should cross, okay, which means it's a cutter, and then if you shove that into the hole, you can reverse it, and then it is a splitter, okay, right, or a spreader, sorry. Okay, so okay, now here we have a small input syringe to a larger output syringe. Okay, so in this case it's 5 ml to 10 ml. Okay, so if you apply the input force, okay, moves it down and it spreads it. Okay, if you reverse it, okay, then it cuts it. Okay, so this is a simple, very simple example of how jaws of life work. Right, of course in real life they use much better materials. They don't use plastic syringes, they don't just use tubing. What you also need to remember is jaws of life equipment must be small enough, it must be compact for one emergency worker or paramedic to be able to use, and then so that they can handheld. Also, in our example over here, we have a 5 ml to a 10 ml, okay, so which is just 2 times bigger. All right, so mechanical advantage is 2. In jaws of life used in real life, they will probably have a much bigger mechanical advantage. So a very small input cylinder to a very large output cylinder, because they want force, they want to cut through metal, or they want to lift concrete or push concrete apart. Okay, so the size of the input cylinder compared to the output cylinder would be much greater, okay, because they want force. All right, so this is basically just a summary of what you already know about hydraulics and pneumatics and what you learned in grade 7, and kind of a little step up on that. Okay, so let's look back at our notes. Okay, so what you will notice now is I have explained this page basically to you guys. Okay, right, then you will also notice that this action research is pretty much what I have explained to you guys sorry, to you guys now as well. All right, the other cool thing is that you can see here is that you can split them. Okay, so there you have 1 input to 2 outputs. Okay, and here you can read about how that works. It is a very cool system. Okay, right, then the next important part that I want us to look at is to just revise the principles of pneumatics and hydraulics. Example questions that I can ask here is things like compare pneumatics and hydraulics, give advantages and disadvantages. So here, very simple, you just work through it. Okay, one of the biggest differences is that pneumatics uses compressed gas and hydraulics uses liquid. Okay, this part here at the bottom is also important, okay, because it also gives you some of the advantages and disadvantages. And here you see a very simple system of a hydraulic system. Okay, small input to large output. Okay, right, then next we move to this page. Right, and you will see that I have, you know, kind of scratched a lot on it and made some notes. Okay, now we get to Pascal's principle. Okay, so from the research that you've done, you see that force transferred through a liquid is related to the area of the piston. Okay, and here I'm just going to very quickly switch to one of the pages in the notes. Oh, come on. Okay, right, so okay, here you can see that pressure is the amount of force that is applied over the surface area of an object. So there you have your cylinder, and you will see that pressure is the force applied in all directions. Okay, so the force that is applied over the surface area. Okay, so here you see your maths comes in where you calculate the surface area of cylinders. Luckily for us, we're not going to do that, okay, right now. Okay, so let's switch back to our document cam. All right, okay. So, what we have here now is, okay, Pascal's principle. All right, it is named after a French guy, Blasé, I can't really pronounce his name, Pascal. Okay, now this paragraph is extremely important. Okay, I can ask you guys to give me Pascal's principle in words or Pascal's principle mathematically. Okay, now a type of question on Pascal's principle can either count 3 marks to 5 or 6 marks. So you study this off by heart. Pascal's principle states that a change in pressure, okay, a change in pressure means, okay, a change in pressure means that I am applying a pressure. Okay, I am applying force. Okay, which means by applying force, I change the pressure. Okay, that a change in pressure at any point in an enclosed system. Okay, fluid is transmitted undiminished. Transmitted meaning passed on undiminished, okay, to all points of the fluid. Okay, so if I ask you to simply state Pascal's principle, then it is that part. Okay, then if I ask you to state and explain, the next part is important. This means that the pressure exerted on one part of a hydraulic system, so when I push the piston of the one syringe, okay, in an enclosed liquid, okay, system with an enclosed liquid, will be transferred equally without any loss. Equally, remember, it pushes equally against all parts of the object, okay, in all directions to other parts of the system. Okay, so this is Pascal's principle in words. Very, very important. Okay, the next part we look at now is we look at Pascal's principle mathematically, because remember, Pascal was a French mathematician. Okay, now to start off, we need to know what is pressure. Okay, what is pressure? Right, so pressure, small p, okay, is equal to the force exerted per unit area. Okay, per unit area. So P is equal to force over area. Remember, per means divide. Okay, so P, pressure, small p, is equal to force over area. Okay, And Pascal's principle says that pressure is equal everywhere. Okay, that the pressure doesn't change because it is an enclosed system, right? Which means the pressure that you have in your input is equal to the pressure that you have in your output. And therefore P1 is equal to P2. Okay, so if the input force F1 and the area of the input cylinder A1 and the output force F2 and the area of the output cylinder A2, then, very important, you always start with Pascal's principle. P1 is equal to P2 because that is what he discovered. Okay, and therefore, because P1 or P is equal to F force over area, P1 will be force 1, so your input force over your input area is equal to your output force over your output area. Now you will see that this is a simple, solve for X kind of problem. So if you want to know what the output force is going to be, you say A2 output area over A1 input area times F1 input force. Okay, so here is a worked example. Okay, so with these, your simple how you do it is you have 4 variables of which one will be unknown. So you say A1, F1, A2, F2. Okay, so when we look at this, if an input force, which is F1 of 50 newtons is exerted on a piston, remember input, so piston A is going to be 100 millimeters squared. Remember, we're working with surface area, and the area of the output piston A2 is 800 millimeters squared. What is the output force? Okay, so you start with P1 is equal to P2, and therefore F1 over A1 is equal to F2 over A2. So if I want to calculate output force, which is F2, it is A2 over A1 times F1. Now we go and insert our information. Okay, so A2, right, is 800 millimeters squared. Okay, A1 is 100 times 50 newtons. You get your answer, 400. Okay, over here, I'm just quickly going to switch over to my book here. Okay, so you know that, pressure, is equal to force over area. Okay, right, and Pascal says is P1 is equal to P2. So input pressure is equal to output pressure. Okay, because what Pascal's principle came up with, is, pressure is the same everywhere in an enclosed system. Okay, Right. So, for me to remember this better, okay, this worked example, P1 is equal to P2, which means, okay, F1 over A1 is equal to F2 over A2. All right. Now, you can go and manipulate this formula mathematically, but what I have noticed is that that is sometimes confusing, and then if you make a mistake in manipulating the formula, you lose marks for the method. Generally in technology, depending on the moderator, sometimes we mark with mistake, but in many cases they don't. All right, so you get the answer correctly, you get the 1 or 2 marks that the answer is, but you lose the marks for the method. All right, so an easy way that I have found to remember the different ones is if I want F1, okay, which is, okay, let's actually start with if I want F2. Okay, if I want F2, which is output force. Okay, if I want F2, which is output force, it equals to, okay, A2 over A1 times F1. All right, now I know in the worked example here, right, they just put everything over together, okay. But what I like about this, sorry that the light is changing, it's a bit cloudy here. All right, what I want is to see the units, okay, to see the units. Okay, and I will show you now when we do enabling task 3.2 together. So F2, nice thing to remember, if it's F2, then it's A2 over A1 times F1, okay. If you want to calculate F1, which is input force, okay, then you have A1 over A2 times F2. Okay, now remember with this, there will always be only one unknown. Okay, as you can see over here, I've given you 3 and there's only one unknown. Okay, sometimes there will be questions that follow on each other where you have to calculate one part, let's say in 1.1, and then use your answer in 1.1 to calculate in 1.2. I want you to not stress about this. I go over this with you guys step for step, so you don't need to worry. Okay, now let's look here. If I want to calculate A2, okay, which is area of output cylinder. Okay, then, okay, it is F2 over F1 times A1. Okay, so do you see again, if it's A2, F2 goes at the top. Okay, and if I want to calculate A1, which is area of input cylinder, then it is F1 over F2 times A2. Okay, so what I've noticed is instead of just manipulating that formula, okay, and just, you know, putting in X and solving for X that way mathematically, what they actually want when I mark this in the memo, okay, is from that to that and then this step. This step is important. Next, you get marks for substitution. Okay, right. So, for this next part, I am somewhere going to do enabling task 3.2 with you guys. All right, so please make these notes. If you'd like, I will take a picture of them and I will also post it on the group. Okay, so let's do enabling task 3.2 together. Okay. Okay, so all of this is in our notes. Okay, now they say do this activity on your own. I'm your caller friend. Okay, so remember, this is a word sum. Okay, this is a word sum. Right, so I'm going to try and see if I can have it that it's on the question as well as on my notes. Okay, so let's read it first. In a hydraulic system, okay, a force of 30 newtons is exerted. Now, with this, you need to know the synonyms. So, exerted, applied, placed. These are all synonyms of input and input action. Okay, exerted on a piston with an area of 100 millimeters squared. If the output force experienced is 90 newtons, what must the area of the output cylinder be? Okay, so output force, okay, in a hydraulic system, a force of 30 newtons is exerted. So F1, input force, okay, on a piston with an area of that. So that is A1. Okay, A1. Right. Then they say if the output force, which is F2, then what is the area? A2. Okay, so now I move to my answer, and this is, remember, same with gears. I told you, write this down. Okay, so we start with F1, A1, okay, F2, A2. Okay, F1 I know is 30 newtons. Remember, it's a force. Newtons because it's force. Okay, A1 I know is 100 millimeters squared. The units are important here, and you will see now because they cancel out to ensure that your answer has the correct unit. They then tell me that F2, okay, is 90 newtons. And then they want me to calculate A2. So you always start with P1 is equal to P2. Therefore, F1 over A1 is equal to F2 over A2. Okay. Now, if you want to calculate, so therefore, okay, therefore, I want to calculate A2. Okay. Now remember, on our previous notes, we saw that if I want to calculate A2, then it is F2 over F1 times A1. Okay. So A2 is equal to F2 over F1 times A1. This step from there to there is important. You actually get a mark for it. Okay, so now let's go and put in let's substitute our numbers. Sorry for the blur. Okay, so A2 is equal to, we know that F2, okay, is 90 newtons. Okay, F1 is 30 newtons. times A1, which is 100 millimeters squared. Okay, now, very important, your units cancel out. You are calculating area, output area, which means your answer must be in millimeters squared. Okay, right. So what you can do next then is you can cancel that out. Okay, so that gives you 3, okay, times 100 millimeters squared, which gives you 300 millimeters squared. So A2 is equal to 300 millimeters squared. Okay, right. Now you can double check that your answer is in millimeters squared because you are calculating area. Okay, because you are calculating area. All right, so this is just the basics of pneumatics and hydraulics. Okay, this is the basics of pneumatics and hydraulics. Right, so I'm back here. Okay, so here I have done one with you. Okay, I've done the example with you. I've shown you how some of the how to calculate some of these. The next section of work which we'll do is the hydraulic press. Okay, here we will look more at distance and mechanical advantage. Okay, but we also start with Pascal's principle. Okay, then we look at the hydraulic jack, where we look at how it works with our reservoir valve, okay, our reservoir and our one-way valve, right? And then I will give you extension, or we will together work through some exercises where we actually practice the work that I've just done with you right now. Okay, so even though the direct next section is not on this, okay, specifically, it is linked. Okay, now the worksheet, the exercise that I'm going to give you is just kind of to help you research and recall, revise hydraulic and pneumatic systems. Okay, when they ask you to do a simple drawing, okay, now we all know that I'm not the world's best artist. Okay, so a simple drawing means, okay, you draw a cylinder, okay, and it has a piston. Okay, then you draw, let's use a different color. Okay, you draw your tubing, okay, and then you have your, okay, other cylinder. Okay, and then they want you to label them. Okay, I want you to label them. So this is input. I don't know whether you can see this clearly. Okay, tube. Okay, and then this one is your output. Okay, right. So when they ask you to draw a simple system and label them, okay, then this is what you do. Okay, so this would be A1 and the pressure there would be F1, the force. Okay, that would be A2 and the force, output force, would be F2. Okay, so nothing major, no major artistic awesomeness, simply a simple drawing. Okay, oh, sorry, my chair is giving me grief. Okay, so the activity that I give you, okay, for homework, sorry, this is my first video, so hang in there with me. Okay, so I'm quickly going to switch back to my document cam. Okay, so this is what the activity or the exercise that I've given you looks like. Okay, so this is just basically to revise your knowledge on pneumatics and hydraulics. Okay, describe what the difference is. Explain the term potential energy. Remember, I told you that technology and science are connected. Science is the theory, technology is the application of the theory. So here I'm checking whether you actually know the theory. You've learned about this in NS. Okay, go and look in your NS textbook. Okay, don't just Google these answers. Actually look in the work that you've done. Okay, here, sketch 2 examples of the molecules of a substance to show how the substance looks when compressed and when not compressed. Okay, so here, the simple type of diagram that you will make, okay, simple type of diagram that you will make is, okay, uncompressed gas, okay, and you know that your particles are, you know, very far apart, okay, versus compressed gas. Okay, the particles are, it's not yet a liquid, but they are closer. Okay, so do you see nothing major, nothing that you guys don't know? This is just, you have to think. You have to think. And you have to believe in yourself, okay? Just as I believe in you guys. All right, then state one advantage and one disadvantage of using a pneumatic system, of using a hydraulic system. Okay, these are in the notes that we have looked at. Okay, there are also, there's also the PowerPoint that I'll upload. Okay, then number 6, sketch a hydraulic system and label the following features. Remember, master cylinder is input cylinder. Okay, there they say input. Slave cylinder is output. Okay, then the piston and the linking tube. Okay, the piston and the linking tube. So if we quickly just switch back to my webcam. Okay, so here they just want you to say input, okay, or master cylinder, output, linking tube, and then your piston. Okay, so here you'll just say piston. Okay, right, so once again a very, very simple system. Okay, then explain how you can multiply force using only a basic hydraulic system consisting of 2 unequal sized syringes. Okay, 2 unequal sized syringes. Okay, 10 mil, 5 mil. Okay, remember the same principles apply as did with, sorry, let me just get the right page, as did with gears. Okay, as did with gears. Remember, they want force multiplication. They want to see how you can increase force. Okay, so here, simple explanation. Okay, what you do is you have a small input cylinder and a large output cylinder. Okay, right. Then describe Pascal's principles. So here, that's that paragraph. Okay, that paragraph. Okay, word for word. Describe means you have to state it and explain it. State it and explain it. Now in this case, I don't want to hear it in your own or mark it in your own words. Okay, this is you study it word for word from here. Okay, because this is the science part. You will notice, and you might have heard from the grade 10s, that terminology you study word for word. All right. So Pascal's principle will make sure that you understand this very well. and that therefore when you do physical science and then in grade 11 you do Boyle's law, which is basically just the next step theory of Pascal's principle, you understand it. Okay, you don't need to do number 9 because number 9 is very similar to question 7. All right, so this activity, I want you to please do it in your workbooks, and then on Friday, okay, I will give you the memo to this, and then if there are any questions, just ask me on WhatsApp, and that will then guide me in terms of the video that I need to put up on Friday. Okay, so Friday might have 2 videos, one in which I address any of the issues that you had here, if there are any, and then where I work with the next section of work, which is the hydraulic press. And here you see we start looking at examples, and we look at newtons, and we're calculating mechanical advantage, and so on and so forth. And we also do system diagrams. You do remember these, we have started doing them, but in grade 9 they give you nice free marks, a minimum of 6 marks, often 9 marks. So we'll make sure that you understand that. Okay, right, so let's see whether I can switch back. Okay, right, ladies, I hope you understood. If there's anything you didn't understand, please talk to me on the WhatsApp group. I will upload these things for you shortly. Thank you very much. It was great being able to teach you guys, and I know that you guys will understand this, and that if you don't, you'll communicate with me. Remember, there's no such thing as a stupid question, and rather ask me and let me explain it again and again to you guys, and then look at the PowerPoint. And then just the very last thing that I want to show you guys is a really cool activity or experiment, practical task that you can do. A few years ago, I actually made my learners build this, and they did it quite magnificently. But with the change of curriculum or of requirements, it has changed a bit. So here's the last, fingers crossed, for showing you this section of the YouTube video. I have also included the link in the notes, and it is also in that planning, I believe, so that you can go and watch the whole video. The cool thing about this is this guy makes a hydraulic crane. Okay, remember in grade 7 you made the electromagnetic crane. This guy makes a hydraulic crane that can turn sideways, as well as pick up a Coke can and then move it, all using cardboard, glue, toothpicks, syringes, and tubing, okay, and some tongue depressors. So I'm not going to show you guys the whole video. I'm basically just going to show you guys the end product, the cool part. You can go and make this if you want to, if you have the stuff available. It is really, really awesome. It's a fun activity to do, and all you need is cardboard, syringes, tubing. Okay, so fingers crossed to see whether I can do this. Okay, right, so okay, so 1 shift alt tab. Okay, then I'm just gonna make this smaller. Oh damn. Okay, go there. All right, here we go. Okay, so I'm gonna make this bigger. Okay, so here you guys can see is the last part where he is connecting it. It's cool. He has 4 different colors to indicate the difference, and then I'm just going to play the last part for you guys. Okay, so what's really cool about this system, and let me see if I can get back to that, is remember in our notes we looked at how you can split it so that you have one input that has two outputs. Okay, so here what this guy has done, instead of splitting it into two output cylinders, he has used a linkage. Okay, just like we did with our jaws of life. So here he has used a linkage, and you will see that this is a machine because it is a combination of several mechanisms. Now I don't know about you guys, but I think this is absolutely awesome, and I love how he made like a kind of a control panel from which you can you know, control this entire machine. So you guys can see it's cardboard, it's toothpicks, it's glue, right, some tongue depressors, some cable ties. You can use wire there as well, some society sticks, and then syringes with tubing. Okay, so I really hope that you guys had fun. Okay, right, I really hope that you guys had fun. Please let me know if there's anything that you didn't understand, and then I am going to mark the worksheet with you guys on Friday, and then I will present, we will carry on with our next lesson, the hydraulic press. Thanks guys, stay safe, love you, miss you, bye.